Hey, this is Zach from ZachMakesGames.com with another quick little update on a project I've been working on for the past couple of months, kind of in secret, and also as a successor to my last project. This is the next iteration of that project. So if you've been paying attention to my last couple of videos, you'll notice that I've been working a lot with maze generators, or at least a maze generator that I had implemented in Vulkan with some C# interoperability for UI. And I had a pretty good implementation. It would generate a maze, it would render it in real time in 3D. I had screen space raycasting for object interaction as well as world partition to make that object interaction a lot more efficient so I didn't bog down on frame rate and things like that. But I wasn't really happy with it, and I was encountering some barriers that were holding me back pretty well, some challenges that I didn't really want to tackle, and that I really didn't need to because I feel like I kind of implemented all of that in a roundabout way when I could have done it a lot better in the first time. So I've got this new implementation, and this is not Vulkan. This is D3D12. This is all C++. There's no C# in this, and it's a pretty good jumping off point. I have also engineered it to be a foundation for many projects, so it's supposed to be a general purpose rendering framework rather than a purpose-driven tool. So this would be a great framework to start with for any kind of debugging app that you want to build, any kind of technical demo you want to build. If you just want to play around with D3D12, HLSL, whatever, you just want to get some objects on screen, a camera moving around a scene, this is a really great platform for that. It's stupid simple to get objects into it the way it's set up. Plus, it gives you a lot of flexibility in how you want to do your rendering. So, the biggest benefit right now is that this is actually running on deferred lighting. So all of this that's being rendered is deferred. We render to the G buffer first, and then lighting is done in one pass just over the only pixels that need to ever be rendered. So that saves a lot of time. I got rid of the C# interoperability. I felt like that was really clunky, and there was a lot of code duplication I had to do between the C# and the C++ side to pass data back and forth between the UI and the renderer. And with the things I wanted to do for that editor, it was going to be so much work. I was going to have to spend so much time debugging that, implementing, tweaking, getting it right. There was just no way that was going to be sustainable moving forward. And then ultimately, I also wanted to get some more experience with D3D12 since I spend all day at work looking over D3D12 implementations. That's what I do as a performance engineer. I look at D3D apps and try and see why they're slow and where we can make them faster. So, not really having this hands-on D3D12 experience was a little bit of a hindrance there. And I've been working on some apps to try and get a better understanding of it at the API level so that when I look at it deeper, I understand what's going on and why some of those things work the way they are. So I've got a little demo scene going on here. Currently, I have 100,002 objects being rendered. Actually, it's a few more than 100,002. But I've got a whole bunch of these little dodecahedron things with textures, which is another improvement, all rendering in real time at about 800 FPS, which is a significant improvement from my Vulkan instance. Even with instance rendering, I wasn't doing deferred lighting, and that was a big performance eater. I have pushed this well over 100,000 instances and and still able to get above 30 FPS, which is very impressive, especially since these all have textures. Obviously, if these were different textures, we would start running into performance issues, but with just a simple test texture, this performs very well, even with all of them being lit. I also have implemented screen space raycasting, and that's what this line is. This is the debug implementation for that. So if I go ahead and hover my mouse over one of these and hit L, you'll see that line goes away. And I've got this little box that represents the camera position in world space and a white line that shows the ray that was cast. And you won't be able to see it, but way, way off in the distance is another green box that will show where that ray would have hit on the far clipping plane. So I can use this to debug and see which objects I'm hovering over, where that ray would go, which will be useful later on when I implement actual object picking and things like that. So by far, this is a better implementation, in my opinion, than what I had. It's also designed in a way to make it modular and adaptable. And that was a big problem I was having with the previous version, was that it was kind of stuck in one mode, one lane. That's all I could really do with it, was move forward in the direction that I had kind of set out on, which would be fine, but it's nice to have an option to branch out, to use this as a jumping off point for any project, basically. And of course, I've got quite a few improvements in this version over the last version. The custom render passes, I have this set out to do custom render passes. D3D12 doesn't do render passes the same way Vulkan does, and I've had a hard time grappling with how Vulkan implements their render passes to start with. It's complex and a little convoluted in my opinion, and figuring out how to make that work nicely um, was a bit of a challenge. So instead, I implemented a custom solution that allows me to throw objects into a render pass that will do everything from pre-render to post-render, and I can control exactly which shaders and which objects are getting rendered at what time, so I can do things like avoid context rolls. I'm organizing the geometry based off of their draw parameters, so that if there were a whole bunch of diversified objects, we wouldn't run into issues with hanging up on context being overused. They would be used in order without jumping back and forth, and that will greatly improve performance in the long run. The deferred rendering is a huge speed up. In my Vulkan implementation, this many objects without the deferred renderer would have been significantly slower, especially with textures. My Vulkan implementation did not have textures, and this one does. So that is a great speed up. Plus, I have IMGUI built in kind of as a first class citizen as well. So I can do things like have a debug window that will show me things like the frame time and the back buffer. And this will allow me to create menus for either an editor, menus for doing debug things, whatever you need the UI for. It's a first class citizen. You can simply just make those calls, create those windows in the update, and they will be there. Very nice to have, especially since I'm not leveraging C# for the UI. And the last thing I've mentioned already is the texture support. So I can add textures to these objects just simply by creating a texture and uploading it and attaching it to the objects, which is something I wanted to do with Vulkan and was really struggling with figuring out a good way to do that. So here I am. This is far from done. Obviously, this is not the tool I need it to be. This is just a simple little tech demo, but I'm pretty happy with it. It came out really well. It works great. D3D12 is honestly a breeze to work with compared to Vulkan, and that will solve a lot of headaches down the line. Plus, I can use picks to debug, and that's something that I'm well versed in and a little bit easier than using things like RenderDoc, in my opinion. I like Pix better. It has its issues, but personally, I think Pix is uh, a more professional option. Don't hate me for that opinion. So there we are. I hope you've enjoyed this little demo. I will be taking this platform and trying to transform it into the maze editor that I had with the previous implementation in the coming months to see if I can get that to be feature rich where I want it to be and add the features that I was hoping to on the previous version, things like being able to edit the maze in real time, The whole reason I implemented screen space raycasting and world partition was so that I could do things like drag and drop obstacles, doors, walls, floors, you name it, whatever it is, or take something that was generated automatically and move it and tweak it, or create custom rooms. There's a whole bunch of stuff that I want to do with this, and having this framework should make that a lot easier to implement moving forward. If you want to check this out, this is available on my GitHub. The link will be in the description below. Please give it a like and check it out. And I hope you've enjoyed. I'll catch you next time.